When I look at this problem, I think about how I'm going to tackle it. First thing I notice is that I'm going to have to factor each one of these into its factored form. So let's take each one individually and do that. We'll start with this top one here, the 4k squared minus 12k plus 9. All right, we can't reduce it, so we have to use another technique. We multiply the first coefficient with the last coefficient, and that's 4 times 9 is 36. So we put a 36 up here. If you haven't seen this before, just bear with me for a minute. It's going to be pretty easy. And then we want negative 12 at the bottom. Now what we're trying to do, we've just seen this in a form. We want two numbers which when we multiply them together give me 36, and when we add them together give me negative 12. The two that come to mind for me are negative 6 and negative 6. What we're going to now do is simply rewrite this in a different form using the negative 6 and the negative 6. So this can be rewritten as 4k squared minus 6x minus 6x plus 9. And as you can see, that's exactly the same thing. The only difference here is we've just taken the 12x and we've made it 2 minus 6x's. Now I'm going to imaginarily split this into two binomials. I'm going to figure out on this side what's common. Oops, this should be a k. And this should be a k. Change to x. Sorry about that. So what's common to this side? Well, both 4 and 6 have the common factor 2, and they also have a common factor of k. And what are we left with over here? 2k minus 3. How about on this side? Has a common factor of 3, so let's take a negative 3 out. And what are we going to be left with here? 2k minus 3. Now we can look at this and say, this is common with this. So now we're going to take the whole thing together and we're going to pull 2k minus 3 out. What are we left with on this side? Simply 2k. And what are we left with on this side? Negative 3. So 4k squared minus 12k plus 9 factors into 2k minus 3 times 2k minus 3. To save myself some space, I'm going to simply take that and rewrite it up here. So this is 2k minus 3 times 2k minus 3. And we'll X that out. I'm going to erase this so we can work on the next one. So we're going to have to do this with every single one of these 4 that we've got here. So let's tackle this one now. 2k squared plus 19k minus 33. Once again, we've got a coefficient in front of our k squared. So we'll have to do exactly the same thing we just did. So let's rewrite it. 19k minus 33. And again, we're going to multiply the first coefficient with the final coefficient. That's going to be negative 66. I'm going to make this a little x. It's going to be negative 66. And we're going to be aiming for 19. So now what two numbers, when multiplied together, will give me negative 66 and add to 19? Let's see. 6 times 11. That's not going to do it. How about 22 times 3? Yeah, that's going to do it for me. I like that. Because one of these numbers has got to be negative. Not that one, but certainly that one. And now when we add those two numbers together, we're going to get 19 as a positive number, and multiply them, we'll get negative 66. So let's do exactly what we did last time. This becomes 2k squared plus 22k minus 3k minus 33. Split it down the middle again. What's common to both of these numbers? 2 and k, right? So we take 2k out and we're left with k plus 11. How about over here? Again, we can take out negative 3 and we'll be left with k plus 11. Be careful with your negative signs here. Once again, this is common to both of them. So we'll do one more step, take that out, and we're left with simply the 2k minus 3. Voila. So this can be factored into k plus 11 times